Hello and welcome back to Let's Develop Conway's Game of Life. In this episode I'm going to continue implementing the universe with the universe tests. And first thing I'm going to do, since all my current universe tests still pass, is I'm going to write a second test. And this test is actually going to handle the case or to ensure that the universe can proceed in its state. So it should update its cells. And for this, I'm of course going to create a new universe. And the universe is going to have a state, an initial state, and I'm going to choose the simplest possible state I can think of that will change with one update, which is just a grid, a 1x1 grid consisting of exactly one alive cell. So after one update, this cell should be dead because it has no neighbors, of course. So yes, I tell the unit under test to update its state. I'm going to quickly create this method. Update is not going to return anything. And after that, I'm asking the unit under test for its new state, which is the actual state. And I'm expecting this state assert equals, which I can import as you remember, assert equals the actually I'm going to write cell state dead in this case to make it more explicit. I'm not going to use these static constants I created up here because I think in this case it's not that good to read. And I'm actually going to assert that this is equal to actual 0, 0. So the one cell that was alive up here should be dead after one round. And this test is hopefully going to fail. Yes, it is. So this means I have to implement some update logic. And again, of course, the easiest thing would be to set this one cell to dead, but I'm not going to do that. I'm going to instead implement the logic as I know I'm going to need it. Which means iterating over all the cells and updating their state. So again, I'm going to type, okay, actually I'm going to copy this logic from up here. To just iterate over the whole state, over all columns, and say for each column, okay, the state row column needs a next state. And for the ease of it, I'm going to insert 0 here as a default value because I don't consider neighbors for now. I don't need them to fulfill my test case. Okay, one point I see now is that this get next state, which is by the way not named according to Java conventions. Sorry, this is the C# implementing that does this strange, confused uppercase, lowercase thing to me. Anyways, what I wanted to say is that this getNextState is not going to update our cell, but it's only going to return the next state. Of course, I could now do something like this, say, okay, we take this cell and give it some set state method where I can change it, but actually I think changing the state of the cell according to the rules is a task that the cell itself should fulfill. This is where this task belongs. So I want to change the semantics of this getNextState method so that it actually is an update method. This has another advantage, that the behavior of the cell implementation with an update method and a getState method is actually equivalent to the implementation of the universe class, where there's an update and a getState method. Okay, as I already did in the last episode, before I start to change a cell, I'm actually going to adapt my cell tests. Because now what I want to have is that the unit under test has some kind of update function. This update function actually takes the number of neighbors, and then I just use the getState function method we created last time to get the new state. And at this point, I think it comes really handy that we refactored our tests with these JUnit params extension of JUnit, because now I really have to change only this one, or let's say these 2 lines of test code here, and all my tests will conform to the new logic. Whereas with my original test design, where it would have actually all these 18 tests written out into a method each, I would have had to update all the 18 methods, which is a pain in the ass. So I adapt the cell tests, and I'm going to adapt the cell and say, okay, this is actually my update method, and it's going to return void, because I don't need it to return anything anymore, and instead it's supposed to assign the state to its internal state variable. So now I have the cell tests that should cover all the cases, so let's see if this still runs. There exist errors, I know, but not in my cell test, so the cell test runs. I'm quite happy with this. I can close the cell and continue with the universe implementation. So now I can just use the update thingy here, and everything is fine. And I even think that by now my universe test should actually run, which is true. Nice. So I think it's actually time for another test, which is probably going to be the last test I'm going to write for this episode, and probably even the last test I'm going to write for the universe. But let's see. So again, there's a universe with an initial state, and this time this state is going to be a little bigger, because to do all this neighbor counting things, I actually need some state to work on. Otherwise, it's just boring. There's no counting, no different counting cases, so I will never see if something gets wrong. And I'm actually going to create, I think, only one larger case here, because I think that one case should cover most of the interesting cases. So let's do something like this. This should be an O. This is another X. Then there's an O here and another O here, and well, let's make it an X here. I just made this up, so this is just one random thing. And what I'm going to write down next is actually my expectation, which is cell state array expected new cell state array. So what is going to happen? So the cell in the upper left corner has 2 alive neighbors, but it's dead, so it will stay dead. The next one in the upper middle, it has actually 3 alive neighbors, so it will stay alive. And this one has 2 alive neighbors, so it will stay alive. Let's see, maybe this is an uninteresting case I chose here, but let's see for a second. So in the second row, first cell, it has only 1 alive neighbor, so in the next round it will be dead. the cell in the middle has actually like 1, 2, 3, 4, 5, all these neighbors, so it will stay dead because it's way too crowded here. And the last one has exactly 3 live neighbors, so it's going to stay alive. And then in the last one, this has 1 neighbor, so it stays dead. This has actually 1, 2, 3 neighbors, well, so it becomes alive. And this last one has 1 neighbor, so it's going to die. Yeah, actually I think this case is not that bad. There's actually quite some change and some things that stay the same, so I think it's a good example. Okay, and now I'm going to call my universe update, and I'm going to ask my universe for its new state. Pass this state into my actual variable and assert equals that my expectation meets my actual. Expected. This should work. Oh no, I have to use. This is actually a nice hint of Eclipse, that since I'm using arrays, I should not use assert equals, but assert array equals, something that goes wrong often at time. Okay, let's see. This test should fail. Actually, I think I can press just here. Yeah, should update all cells is failing. So I'm going to implement the respective logic, which is actually quite complicated because I have to count all the neighbors and I have to consider all the corner cases where there are no neighbors because the grid actually ends. So I'm going to extract this logic into a get number of alive neighbors helper method here, and this is going to be an int number of alive neighbors, and I'm going to pass this in here. Let me see if Eclipse can create this method for me. Actually it can, which is quite nice. Okay, now I have a couple of cases I want to cover here. First case is, okay, if, oh actually I missed something. I need to pass my row and my column in here, otherwise I don't know what to look for. Change method, add arguments, row, column, sounds good. So if my row is bigger than 0, which means I have a row above, then row above is actually row minus 1. If I now have that cell is greater than 0, it's not cell, it's column, sorry. If the column also is greater than 0, then I have actually also a column to the left. And I can check whether the state, row, column is alive. Oh, let's just use the get state for now. Equals cell state alive, and if that's the case, number of alive neighbors is going to be incremented. This is a local variable which I'm going to create here. I'm going to initialize this for the compiler not to complain. And in the end, of course, I'm going to return this. So, first case. Since I have a row above, I in any case have... oh, actually, this should be row above here. I actually have that row above. I know that this exists. And actually, this should also be column minus 1. And in this case, should be column. Oh, I would have made mistakes over mistakes. Whoops. Thanks, code completion. That was nice. Going to implement this. Same test. Cell state alive. Number of neighbors plus plus. If column is smaller than state row length -1, and if the state row above column +1 get state is cell state alive, then again I'm going to update my neighbors. Okay, now I implemented the case that I have a row above, and I checked all the 3 cells in the row above, the one to the left, the one immediately above, and the one diagonally to the right. And now I have another case that actually looks quite the same, which is that I have a row below. So row is smaller than state dot length -1. Row below, and in this case it's actually +1. And I'm going to do the exact same things here, because I again have to check the one diagonally to the left immediately below and the one diagonally to the right. And what's left now is actually only 2 cases, which is the cell immediately to the right and the cell immediately to the left, which is again a quite similar thing actually. The cell itself is not going to be counted because I only count the neighbors here, and this is just checking for row length -1. This is the same rule, so this should actually work. Let's see what happens. Oh no, this test is failing because actually something went wrong. Okay. Let's have a look into this. So let's go back to the test and let's see what actually went wrong. So in the expected element in the second row, or actually in the third row because we are null based, in the second column there was expected something to be alive, but it was actually found to be dead. So this is this exact cell here, I'd say 0, 1, second or third row, and the column with index 1. This I did expect to be alive, but it was actually dead. Okay, why does this happen? It had originally 3 alive neighbors, but apparently my counting thing just does not work, so it's not going to be alive. The reason I know this is because I have tests for my cell, and I know that the update logic works. If there are 3 live neighbors for that cell, it's becoming alive, so the problem is not my cell logic, but it has to be in the counting logic. The error has to be in the counting logic. So what I figure is the problem is that I'm going through these state cells one by one, and I'm updating them, which means when I arrive at this particular cell, which is dead in that state, I count actually not the original state, the number of alive neighbors in the original state, so the number of alive neighbors in the partially updated state. As you can see here, this one is going to die in the meantime, so it's already dead. This one is staying alive, so it does not matter. This is not yet processed, so it's alive, but it does mean that the number of neighbors that are alive are actually just these 2 cells, so he's counting only 2, and it's not going to update this one to alive because 2 neighbors do not make my cell become alive. So the problem actually is that I'm working on some partially updated state, and I should work on the complete old state. So let's fix this. What I'm going to do is, instead of working at the actual state and live updating the state, I'm going to work on a representation of that state, which I can get from my getState method. I should actually use this, so cell states, use this for counting the neighbors, and in this case it doesn't matter that I update the original state, because I do all the counting on a copy I created via the getState thing. So I pass this cell state in here, which I just copied. I'm going to add the parameter, even though the quick fix doesn't offer this option for me. So this is going to be my state here. And the state, I can now quit, just skip all these calls here, which is quite an easy change. And after that, hopefully all my updating will work. Let's see. Now, why isn't this called? There's actually some incompatibility, but I currently don't see why it is incompatible. Let's see. Cell state cannot be. It's the same mistake I did like 2 episodes ago, I think, every time, all over again. I call it cell state instead of cell states. So now everything works again, and let's see if this fits my testing requirements. And actually it does, which is really nice. So now I know that all my testing problems are actually resolved. Nice. So I think I'm going to stop the development here, because a lot of time passed, and this is actually a pretty long episode already, but since all the tests are green, I guess it's a good point to stop here and continue on next time. See you around.